Hello everyone, my name is Raina DeJute and this is my Module 14 technical demonstration and code overview for the Rocket Food Delivery mobile app. This module is a continuation of Module 13, kept the same repository and extended the existing customer app with a full courier section, role-based navigation, account management for both roles, notification opt-in, brand typography, and a Google Maps restaurant view as the extra mile feature. In this video, I'll do my best to explain not just what each feature does, but how it works under the hood. If I made any choices that differ from the grading sheet wording, I'll explain why I made that decision as I go through. So let's get into the project setup and structure. So first, let's do a quick overview of the README document to get familiarized with what this project is. The README document is updated for Module 14. It covers the project title and description, the full tech stack, including the new dependencies added to this module. The project structure, installation instructions, including the two things someone running this cold needs to know. So you have to run npm install with the legacy peer deps flag because of a peer conflict Expo router's web dependencies pulled in. And there's a metro config.js that pins Metro's resolver to client node modules to prevent a dependency shadowing issue from the sibling project at the repo root. Those two things aren't obvious and they would block anyone trying to run the project fresh without the README flagging them. There's also an environment variables, API documentation, and author section. The module required a specification-driven AI workflow, so I have the global AI spec.md and 7 feature specification documents, one for each feature. The global spec covers the project architecture, the full API contract, allowed tech and constraints, coding standards and conventions, and the global definition of done. Each feature spec covers the goal of the feature, requirements breakdown, interfaces involved, data and behavior, and acceptance criteria. These were written before implementing each feature and used alongside the global spec to guide Claude Code. I followed the process Coach ET recommended, which is write the spec, prompt the AI with both documents, review the output, and iterate on the spec if needed before touching the code manually. So now let's get into the UI and wireframes. So on the left side, we see the app that I have built, and on the right side behind me, we see the wireframes that were provided to me. The Rocket Food Delivery color palette is used throughout, the primary orange-red for buttons and active states, dark secondary for headers and modal backgrounds, green for success and delivered states, red for error, and pending states. These are all defined in a source constants colors.js and referenced consistently across the components, so there's no hard-coded hex values in any of the feature files. So if we log in real quick, so now that I have my email and my password entered in, we can log in. Before I hit login, I want to mention that every screen except login and account selection, which we'll see in a different account, has the header with the Rocket Food Delivery logo and the logout button, content in the center, and footer tabs at the bottom. So let's log in and take a look. As you can see, we have the same consistent header and footer with tabs. The header bar component is mounted above the tab navigator, so it stays pinned across all tabs without remounting. I'll show the code for that in just a second. The app uses Arial, which is React Native's default system font, and then Oswald for any headings and emphasis. Oswald is loaded at the root layout level using Expo font and the @Expo Google Fonts Oswald package, so it's available app-wide before any screen renders. And if we take a look at client app layout.js, this is the root layout. So this layout.js file that's in the root of our app folder is what is considered the root layout. And as we can see right here in this constant fonts loaded, use fonts Oswald. So here, use fonts, it loads under the name Oswald. That's intentional because font family Oswald is what the screens and components reference, so I didn't have to touch any of the existing style definitions. So while the font is loading, the app shows the splash screen. Once it's loaded, the full app renders. This means users never see a flash of any unstyled text. And back on the UI, we can see that any screen with overflowing content is scrollable. The restaurant list, the order history, and once we switch over to the courier side, I'll show you that it is the same on the courier account view. So now let's take a look at the navigation structure of this project. The grading sheet asks for a root level stack navigator in app layout.js that manages the authentication flow and main navigation structure, handling the transition from login to role selection to role specific sections. My implementation satisfies this requirement, but I want to be transparent about how I chose to structure it because it's slightly different from what the wording implies. So in app layout.js. This is the root layout. It sets up global providers. So we've got this safe area provider and this auth provider. It loads the fonts, wraps everything in an error boundary, and then renders the root inside of stack that all routes live inside of. It is the root level stack navigator. The logic for the authentication flow, so deciding where to route based on token, role, and session state, lives inside of the child layouts. So if we take a look at app auth layout.js, this handles the not authenticated go to login redirect. App index.js handles the role-based dispatch, customer only, courier only, or dual role selection screen, as we can see right here. And then if we look in app layout.js, this protects the customer group. And then if we finally take a look at courier layout.js, this protects the courier group. So I chose this approach because it keeps the routing logic where it's close to the routes it affects, and it means layout.js doesn't need to re-render its entire tree every time auth state changes. The root layout stays stable, the redirects happen at the boundary closest to where they matter. This is actually the pattern Expo Router's own documentation recommends for this architecture, so that's why I chose to do it this way. The root stack does manage the authentication flow and navigation structure. It just delegates the decision logic to the child layouts rather than containing all of it itself. So back on the simulator, we are on a customer login right now. So this is what a customer sees. So inside the app group, app tabs layout.js defines the customer tab navigator with 3 tabs. So we've got restaurants, order history, and account, which can be seen as well right here on the simulator. The header bar is rendered above the tab navigator, so it stays mounted across all tabs. And if we log into a courier account, so the courier app has its own tab navigator in app courier tabs layout.js with 2 tabs. So we've got deliveries and account. It mirrors the customer tab structure, but it's completely separate. So now let's talk about the role-based navigation. So as you can see, the email I entered in here is the both@gmail, which is a dual role account. So when we hit login, we see this screen come up where the user can choose customer or courier account. This screen is not in either app directly, so it's not inside of the customer app or the courier app. Screen has no header and no footer tabs matching the wireframe exactly. It shows the Rocket Food Delivery logo, select account type, and 2 option cards, customer and courier. The routing logic for this lives in app index.js. So after login, it reads user customer ID and user courier ID from the auth context. If only customer ID is set, then it routes directly to the customer app. If only courier ID is set, it routes to the courier app. If both are set, it checks whether a selected role has already been persisted from a previous session. If yes, it skips the selection screen and routes directly. If no, then it shows the selection screen. Something worth mentioning, I found a bug during implementation where courier ID wasn't being normalized correctly in auth context.signin. The login response uses courier ID in snake case while customer ID was explicitly mapped to camel case. Courier ID was only coming through via a spread operator as courier_ID, so user.courierID was undefined for all courier accounts. I fixed that explicitly in the session user mapping, and I found this by added logging and tracing the value through the auth flow. A customer-only account equals no courier ID in the login response and routes directly to the customer app with no selection screen. A courier-only account routes directly to the courier side and also bypasses that selection screen. On a warm launch, the previously selected role is read from async storage alongside the token and user object. So a dual role user who picked customer last session comes straight back to the customer app without having to see the selection screen again. Logging out clears selected role from async storage so the next login shows the selection screen again. So now let's talk about the courier side. So when we choose courier, The courier homepage is called My Deliveries. It shows a table with 4 columns: order ID, address, status, and view. The list is populated by 2 separate API calls merged client-side. So if we take a look at our screens folder, and we are in courier order screen.js. So the first call is get API orders pending. This returns all orders with a status ID 1 and no courier assigned. Any courier can claim these. The second call is get API orders type courier ID. This returns orders specifically assigned to this courier who is logged in at any status. The 2 lists are merged, deduplicated by order ID, and sorted by order ID descending. This way the courier sees everything relevant to themselves in one single list. So we can see we load the orders assigned and pending. Now if we take a look at the status button, the status button color matches the current order status. So pending is red, in progress is orange, and delivered is green. These map to the color tokens: accent for red, primary for orange, and success for green. And if you can see, when we hit a pending button, it switches to in progress. This is order advancing. So tapping a pending button does 2 things, and this is the part that Coach ET called the challenge in the video walkthrough. First, it calls put API orders ID with order status ID 2 to advance the status. Then, only if the first call succeeds, it calls put API order ID courier with the courier's ID to assign them to the order. I want to highlight the second endpoint because the URL is actually singular, API order, not API orders. I caught that inconsistency early and made sure that the service function used the correct path. And the logic for this button lives in the backend already inside of the order API controller.java. Advancing an order from in progress to delivered is a single call. Put API orders ID with order status ID number 3. No courier assignment is needed since that already happened. And once we press an in progress button, it advances to delivered. The status button renders with the reduced opacity and no on-press handler. It's visually clear that it's locked, and tapping it does nothing. No further transitions are possible once it has hit the delivered stage. Tapping a view modal opens the delivery detail modal, so it shows the delivery address using street address and postal code from the API, the restaurant name, order date, an itemized product list with prices formatted to 2 decimal places, and the total. The structure mirrors the existing order history detail modal for consistency. Tapping the overlay or the X closes it. Then we pull down on the deliveries list to refresh the page. Pull to refresh refetches both endpoints and re-merges the list. So if another courier claimed an order while you had the app open, a refresh would remove it from your pending list. Then if we take a look at the account details, the account page shows 3 pieces of information. So at the top, we have logged in as customer or courier. Then we've got the primary email, which is the login email, and this is read-only. Below that, courier email and courier phone, which are editable fields. There are helper captions underneath each field matching the wireframe, and then the update account at the bottom. So if I wanted to, I could click in here and edit this phone number or edit this email. A couple of implementation notes worth mentioning. The grading sheet listed the get endpoints as get API account ID and the save endpoint as post API account ID. When I inspected the actual backend controller, I found the discrepancies. The get endpoint makes no type parameter, only the ID, and the save verb is put and not post. I coded against the actual backend behavior and noted the discrepancy. The type parameter is required on the put. Accepted values are customer, courier, or employee. On validation, the backend only enforces null checks. Empty strings pass through and get saved. I match this behavior on the front end rather than adding blocking client-side validation that the backend doesn't enforce. This is a deliberate decision in the account details feature spec, including the known behaviors empty string persists, and if both fields are null, the service skips the update entirely. And now if we check out the order confirmation modal, let's create an order. And as you can see, the order confirmation modal now has 2 checkboxes below the order total. So we've got by email and by phone. The prompt is, would you like to receive your order confirmation by email and or text message? When the order is confirmed, the button disables and shows in progress. while the API call is pending, so the user can't double tap. On success, the modal times out and closes on its own after 5 seconds. And now let's talk about the extra mile implementation. So the first extra mile is a Google Maps view of the restaurant list. There is this toggle button at the top of the screen. Tapping it switches between the standard card list and the Google Map view. The map shows all restaurants as pins plotted and their real addresses. This was a little bit complicated because the database is seeded with fake addresses, so I had to use the provided repository on GitHub, copy some addresses, and then do a query deleting the addresses from the existing restaurants and then adding these real addresses in there. Tapping a pin shows a call out with the restaurant name, rating, and price range. Tapping the call out navigates to that restaurant's menu, the same flow as tapping a card in the list view. To make this work, I needed to extend the backend, so the original Get API Restaurants response only returned ID, name, and price range and rating, no address data. So I added street address, city, and postal code to the API Restaurant DTO and extended the two native queries in Restaurant Repository with a left join in the address table. The app then geocodes those addresses using the Google Maps geocoding API to get coordinates for the pins. One thing I want to be honest about, the restaurant addresses in the database were seeded with Java Faker, which generates plausible looking but fake address combinations. I replaced them with real addresses from the RAD repository the grading sheet referenced. Another extra mile was that I tested on both iOS and Android via Expo and Chris Clark's Volunteers to confirm that the UI is consistent across platforms. The layout, colors, fonts, and interactions behave the same way. Having both simulators up tends to make my computer work very slow, but as you can see, the UI is the same on a Google Pixel as it is on the iPhone. And there we go. So I believe that covers all of the Module 14 requirements. To recap what was built, a role-based navigation with a dual role account selection screen, a full courier section with the status progression and delivery management, account management for both customers and couriers, notification opt-in, checkboxes on the order confirmation, Arial and Oswald brand typography, and the Google Maps restaurant view as an extra mile. The biggest technical challenge for me in this module was actually the navigation migration. So I moved the entire app from React Navigation to Expo Router, which involved rethinking how the authentication gate works, how route params are passed between the screens, and how to avoid the login flash on warm launch. That's something I'm planning to cover in the concepts video. So that's all I have for this week's video. Thank you for watching, and I will see you on the next one.